What's up, guys? We're here today. We're talking about transformations. All right. So, transformations are literally just taking shapes and moving them, basically. So, we'll talk about a couple different kinds today, talk about the things that they mean. So, we'll start with some notes here. To transform a shape or figure means to just change it. So we can change the size, location, or direction that figure is facing. So the shape before the transformation, we just call that like the image or the pre-image. That's like our original. So we would call it like, if it was a point, we'd call it point A. Okay. Then once we change it, so or after the transformation, we call it the image. Or we call it a prime after we change it. Okay? And we'll talk about what that looks like down below here. So the first one we're going to talk about is called a translation. So a translation is what we like to call a slide. Okay? So you can imagine our image or our pre-image is right here. We labeled that A, just like we talked about up here. You can imagine taking this and just sliding it right down over the top of this one and calling it A prime. Nothing changed about the picture. We just moved it to a new location. So we've got the pre-image here. We slid it down, and we got the image over here. Okay? That's translation. The next one we're going to talk about is reflection. So, reflections, the key word we use is like flip, or sometimes we say it's a mirror image. Okay? A reflect mirror. That's kind of where we get that. So you can imagine our pre-image here on the left side, because that's just called B, is being flipped over this axis here. So you're taking this and you're flipping it onto the other side. Okay? So you'll notice that like the eyes are all like towards the middle. They're not in the same location like they would be if we slid them. They're reflected over or flipped over. Okay? So those are reflections. The next one we're going to talk about is a rotation. So the key word we use here is a turn. So we've got C here, our pre-image down here. And what we did was we took it and we rotated it. We turned it so that it was around this like origin here. We turned it as we went around, okay, to get our image here. So a rotation is just a turn. And then the last one we're going to talk about is a dilation. Okay, so dilation just means to enlarge or reduce your figure. So you can see D here is our pre-image. And then we took it and we made it smaller to get our image here. So that's a dilation. It could also get bigger. It just depends on what we're trying to do with it. Okay? So we see these things in the real world sometimes. So like translations, you can think about like a conveyor belt moving something down the line. Okay? Something like that. For reflections, obviously looking in the mirror or looking in a pond or something like that. So like looking in the water or looking in the mirror. Rotations, you probably see one every day with like the wheels of a bus or a vehicle of some kind. And then lastly, dilations. You probably don't see them, but your pupils enlarge and dilate based on how much light is in the room or outside or whatever. So you see those dilations in real life as well. All right, then we're going to go on to the next page here. So the next page talks about congruence, or the same, and then orientation is just kind of like how they're set up. So a transformation that preserves congruence or keeps the same size and shape of the figure is called a rigid transformation. So when things stay the same, it's called a rigid transformation. So the orientation of the figure refers to whether or not the figure is facing the same direction on a coordinate plane after a transformation. Okay, so when we talk about that, we're going to talk about the vertices. Okay, and I know that's a pretty strange word there, but vertices are just like our points. So like in this triangle down here, our points are A, B, and C. Those are our vertices there. So it refers to the order in which the vertices are labeled, clockwise or counterclockwise. Okay? So our first one here, why don't you tell me what type of transformation that is? And then we would know that it is a reflection, because you can imagine if there was a line right here and you took this and flipped it over, it would end up, the C would flip to there, the B would flip to there, and the A would flip to there. So the size is the same. The orientation of the figure, though, is changed. So if I start at A here and I go clockwise, that's this direction, I would have the order A, B, and C if I went around like that. So if I did it the other side and went clockwise again, my order is going to change. Okay, so the orientation of my figure is changed, and also the vertices are also changed as well. So that is not a rigid transformation there. All right, our second one here. This is just a slide. So if we take this triangle, you can imagine moving it this way. This A would line up here, the C would line up there, and the B there. So this is a slide, which we know slides are translations. So the size of the figure is going to stay the same. The orientation, so if we did a clockwise, A, B, C, clockwise, A, B, C, so the orientation is the same, and the vertices are in the same positions as well. So translations are rigid transformations. All right, down here on our third one. So we've got a bigger triangle here that reduces down to this smaller triangle here. Whenever we have a change in size, we are dealing with a dilation. So for dilation, the size changes. Obviously, it got smaller here. The orientation, though, is still like ABC. If I go clockwise, ABC clockwise. So the orientation and the vertices are still the same. Okay? And then our last one here, well, the only one that's left, we know it's a rotation. So you can imagine if I take this and I turn it so that the A's match up, that's a rotation. So with the rotation, the size stays the same. The orientation of the figure changes, so it's not in the same like position anymore, but the orientation stays the same. So you can imagine if I start at A and I go around clockwise, it would still go A, B, C. If I start at A again and I go clockwise, I'd still get A, B, C over here. So the orientation of the vertices still stays the same. And that's the basics of transformations. Thanks for watching, guys.